So these are the notes for our motion graphs. So we've learned about position time graphs and velocity time graphs. And we have our note cards on those. And remember that you can use your note cards on tests and quizzes, so don't lose those. So on one side of our note card, we have position time graphs. And on the other side, we have velocity time graphs. Now with a position time graph, or also we've called this a distance time graph, we are graphing our position or our distance in regards to the time. So position or distance is on the y, and then time is on the x. Time is pretty much always on the x-axis. So you're graphing how far you're going as time goes by. So if your graph is going up, that means you're moving forwards or to the right as time goes up. And if your line goes down, that means that you are moving backwards as time goes on. If you have a flat line, then that means that you are not moving on a position time graph. And if you have a curved line, then you are accelerating. So those are the main lines for a position time graph. For a velocity time graph, we are graphing our velocity, how fast we're moving, in regards to time. Again, time is on the x-axis, so velocity is on the y. So that means that as time goes by, you're graphing how fast you're going. So if your line's going up, that means you're going faster and faster and faster. So that's acceleration. So you're accelerating if you have a line going up. Velocity, if you have a straight line or a flat line, that means you're going at a constant speed. Now remember, on a position time graph, a flat line meant that you were stopped. But on a velocity time graph, a flat line means that you're going at a constant speed. So it's different. And that's because for a position time graph, when you find the slope, okay, the slope is the rise over the run. So you're doing your distance divided by your time. That's how you find the speed or the velocity. If your slope is positive, you have a positive velocity. If your slope is negative, you have a negative velocity. Okay? Now for your velocity time graph, your rise over your run is the velocity divided by the time, and so that slope is going to be acceleration. You can find your acceleration by getting the slope of your line. So if there's no slope, like a flat line, then there's no acceleration. You're going at constant speed. The only time velocity is 0 is if it's right on the x-axis, because that's when your v equals 0, is right on that x-axis. You can also have lines below the x-axis with velocity. You can be going in negative velocity. So if you're above the x-axis with the velocity time graph, you're going in the positive direction. If you're below the x-axis on a velocity time graph, you're going in the negative direction. Because up here your values for velocity are positive, and down here they are negative. So just be careful that you know the two different graphs, that they have different meanings and what those are. For a distance time graph or a position time graph, remember that your y-intercept is your starting position. Okay, so up here on our graph, our y-intercept was 0. So that's where it intersects on the y-axis, and that's your starting position. If you have a positive slope, that means that your line is increasing. Then you are moving away from start. Negative slope means that you are heading back to the start in the negative direction, to the left. No slope or a horizontal flat line means that you are stopped, you are not moving. Your velocity is 0. And the steepness of the slope will tell you how fast you're going. If you have two lines and you have one that is steeper than the other, then this line is going faster than the one that is not as steep. So distance time graphs show how the distance is changing as time passes. Slope is rise over run, and that's going to give us distance divided by time. And we know that that is the same formula for speed. So speed uses distance divided by time, and velocity uses displacement divided by time. So be careful, because you can find distance and displacement on a distance time graph. Remember, with displacement, you only care about the first point and the last point. And with distance, you've got to add up all the segments in between. So here's an example of a velocity or a position time graph. This is the same thing as a distance time graph. So if you look at the lines here, A is increasing. It's going to have a positive slope, so it has a positive velocity. It is a straight line. It's not a curved, so it does have a constant velocity. You are not accelerating. B, also positive constant velocity. You are increasing your position. You're moving forward. But notice that A is steeper, so A is going to be moving at a faster rate than B. D is the one that is going down, so you are moving to the left. So you have a negative constant velocity, again, not a curved line, so no acceleration. And C, you don't have a velocity because you don't have a slope. You are staying at the 6-meter position for this whole 10 seconds here. You're staying there the whole time, so you don't have a velocity. And then also remember that we can have a curved line. Oops, let me try that again. There we go. So let's label this line E. So E, it's curving upwards, so that means that you have a positive acceleration. The line is curved and it's curving upwards. So positive acceleration. It's getting steeper as it goes up. So that means that your velocity is increasing as you go up. All right. So here's just some more lines to look at. Again, moving away from start at a constant rate. The blue line is moving towards the start or in the negative direction at a constant rate. The green line is stopped. This line is positive acceleration, and this line is negative acceleration. So this line curves upwards, it's positive, and this line curves downwards, so it's a negative acceleration. Velocity time graphs. So velocity time graphs show how the object's velocity is changing as time passes. The slope is rise over run, or velocity divided by time. So that is actually the formula for acceleration. So acceleration is the change in velocity over the time. And so the formula looks like this. So whenever you see change, you can write a triangle. So the change in the velocity divided by the time. And when we mean change, we're going to subtract our final velocity and our initial velocity to find the difference, to find the change, and divide that by the time. So you're going to do final velocity minus initial velocity divided by the time. And do be careful, because these graphs don't say anything about your location. Okay, they don't say anything about your location or your distance. You can figure out the distance by doing a little math, but they don't say anything about your location or your distance. They only tell you the velocity you're traveling. So you don't know your starting position or your ending position. You know how fast you're going, and you know the direction, and that's all you know from a velocity time graph. So here are some lines on a velocity time graph. So red line is down here. You have constant velocity, but notice that it is below the x-axis. So it is negative velocity here. You're going backwards. Negative velocity. It's a flat line, so you don't have an acceleration. Okay, there's no acceleration because it's flat. But remember, a flat line does not mean stopped. It means constant velocity for a velocity time graph. Green line. Same thing, except now your velocity is up in the positive range, so you're moving forwards. So moving backwards, moving forwards. And it's constant, so there's no acceleration. Yellow line. It's got a positive slope, so you have a positive acceleration, and it's a straight line, so your acceleration is constant. So your speed is increasing over time. Velocity is increasing over time. Let me see. And the blue line. So blue line is here. So that's a negative slope, so you have a negative acceleration. Again, it's straight, so it's a constant negative acceleration, and your velocity is decreasing over time. The pink line, it's curving upward, so you have a positive acceleration, but it's not constant because it's increasing at, the slope is increasing. The slope is not constant, so it's a curved line. So you are accelerating in the positive direction, but not, you are accelerating, your slope is positive, but you are not accelerating at a constant rate. And same thing with this one, except it's negative. It's curving downwards, so it's accelerating at a negative rate. And then the only time that you would be stopped is where the line hits the x-axis. So all these lines that hit the x-axis, you are changing direction. You're going in the positive direction up here, and then in the negative direction when they switch down below. So here's a velocity time graph. So here's your axes, and then here's the line. Notice that the line is flat. So that means that you are going at a constant rate of 200 centimeters per second. It's up above the x-axis, so you are moving in the positive direction or to the right at a steady rate of 200 centimeters per second. For this velocity time graph, it starts out, they're both flat lines, but we start out in the positive section. So here you're moving forwards at a constant rate, and then you turn around and go backwards at a constant rate. This is the positive section, and this is in the negative section of the graph. So above the x-axis is to the right, and below the x-axis is to the left, because this is a velocity time graph. So make sure that you're paying attention to whether the graph is labeled as a distance or position time graph, or is it labeled as a velocity time graph. And then you can look at your index card to help you determine what the lines mean. Another velocity time graph. So here we have an increasing velocity, so the velocity is increasing over time. So that means that we have a positive constant acceleration, and it's above zero. So we are moving forwards. And then we go at a constant speed of 8 meters a second. So we are speeding up, and then we go at a steady 8 meters per second. So again, for a velocity time graph, if your line is increasing, moving in the positive direction above zero, you have a positive acceleration. If your line is flat, you're moving at a steady speed or a constant velocity, your acceleration at that point is zero. When you have a negative slope in the positive section of the graph, that means you're slowing down, and that would also mean that you have a negative acceleration on the positive section of the graph. And then when you have a positive slope, but it's an increasing positive slope, it's a curved line, that is still positive acceleration, but it's increasing positive acceleration. It's not increasing, it's not a constant slope like this one, it's this curved slope. So it's an increasing slope. So positive slope means positive acceleration. Negative slope means negative acceleration. This is on a velocity time graph. And no slope or a horizontal line, a flat line on the graph, means that you're going at a constant velocity, not that you're stopped. You're going at a constant velocity. That just means that your acceleration is, you're not accelerating. You're not changing your speed. You're not increasing or decreasing your speed. Okay, so those are velocity time graphs and position time graphs.